In most of the programming language, we need to declare string variables in our application as per the requirement. And also we have to modify those values if it's necessary. So let's understand string class in C# and string variables in C#. A string in C# is actually an object of string class which is available in system namespace, which contain properties and methods that can perform certain operations on strings. A string is a sequential collection of characters that's used to represent text. String represents text as a sequence of UTF-16 code units. So as we are aware, whenever we declare any string variable in our application or any programming language, it is a collection of characters. At the language level, string is just a convenient alias for System.String class. At the runtime level, when you declare a string, you are instantiating an object of System.String class. So whenever you declare any string variable, at background, it would be creating object of System.String class. A string variable contains a collection of characters surrounded by double quotes. So suppose if you want to declare a string variable in C#, then this is the syntax of it. So string is the data type, this is the variable name, and this is the value we are assigning to that variable. So as we are aware, string is a sequential collection of characters. This is the character array or collection of characters which we are assigning to string variable. So at background, this syntax would be converted into like this. So here with the help of new operator, we are creating the object of string class and we are passing that value to constructor and converting that string into the character array. So at high level, the syntax would be this, but at background level, we are creating the object of string class only. So the namespace would be system and the assembly would be system.runtime.dll. So in this assembly, we can found the system namespace, and in system namespace, we can found string class. Most of the time we have heard about strings are immutable in C#. So what is immutability? Strings in C# are immutable, meaning their value cannot be changed after they are created. Any operation that modifies a string like concatenation creates a new string object in memory instead of modifying the existing value. So let's understand with the help of this example. So here we have declared one variable original and the value would be hello. So in stack memory, there is a original variable and actual memory would be allocated on heap, which contains hello. Memory address would be 112. After that, we are printing the value of original, so the output would be hello. Then we are modifying the value of original variable to hello world. So instead of modifying the existing value, it will create a separate memory. So initially, this variable is pointing to 112 memory location. Now we have modified the value of original variable. So instead of modifying this existing object, runtime environment will create a separate object to store new value, which contain hello world, and the memory address would be different. And now it is pointing to new memory location, and this object would be available for garbage collection. So GC will take care of it. So instead of modifying the existing value, it will create a new object if we modify the string variable in C#. So that's why strings are immutable in C#. So the output would be hello world. So why strings immutable in C#? So the first reason is memory optimization through string iterating. So what is string iterating? String iterating is a mechanism where identical strings literals are stored in a single memory location in a pool. That pool called the string eaten pool. If strings were mutable, modifying one string would accidentally change all other references to the string in the pool, leading to unpredictable behavior. When you assign a string literal, the runtime environment will check if an identical string already exists in the pool or not. If it exists, it assigns the existing instance to the variable. If not, then it creates a new string instance and also adds it to the pool and then assign it to the variable. So let's understand with the help of this example. So here we have declared one variable s1. This is heap memory. Now S1 is pointing to 112. Now again we have declared another variable S2. So in stack S2 would be declared. Instead of creating the new object for S2, runtime environment will check whether that value is available in pool or not. String eaten pool. So it will check in that particular pool whether the similar value is available or not. Yes, it is available. So S2 is also now pointing to the same memory location. So S1 and S2 are both pointing to the same memory location. Now we are declaring third variable S3, which contains hello, but the case of the character would be different. So here H is capital and H is small. So these two values are different. So in eaten pool, only the hello string is available, but this hello is not available. So it will create a new memory for it. And now S3 is pointing to this memory location. So if strings are not immutable, then suppose we are modifying the S2 variable in our application. So due to this, S1 and S2 are both pointing to the same memory location. Even if we are modifying the S2, S1 will get affected. So that's why strings in C# are immutable. So with the help of reference equal method in object class, we are comparing whether S1 and S2 are same or not. So the memory address would be same for both. So that's why the output would be true. Because hello in S1 and hello in S2 are same and memory address is also same, 1112. So hence it will return true over here. So the next reason is thread safety. Immutable objects are inherently thread safe because their state cannot change after creation. Multiple threads can work with the same string instance without the risk of data corruption because strings are immutable. So instead of modifying the existing value, it will create a new value. So that's why if two threads are working on same string, if one thread is modifying that value, then another thread cannot be impacted. This eliminates the need for complex synchronization mechanisms when working with strings across threads. So the next reason is hash code consistency. As we are aware, strings are often used as the keys in hash-based collections like dictionaries and hash tables. If strings were mutable, their hash codes could change after being added to such collections, breaking the data structure's integrity. So if you are aware of dictionary object or hash table object in which the value would be stored in key and value pair. So suppose key is a string variable, so key must be unique and cannot be modified. So that's why strings are immutable in C#. The next reason is simplifies programming. When a string is immutable, developers don't need to worry about unintended side effects of modifying a string. Any modification of a string results in a creation of a new string object. So these are the reasons. That's why strings are immutable in C#. So the next reason is security. Immutability prevents malicious or accidental modification of a string data that might be used in sensitive operations like, suppose there are file paths, connection strings, and user credentials. So those values must not be modified during the application running. So in that scenario, strings are immutable. That's why those values cannot be changed when the application is running. So the next topic is strings properties. So as we are aware, string is a class which contains different properties and methods. So the length is the property which is available in string class. The length of a string can be found with the length property. So here we have declared one variable txt which is of type string class, and the value is CyberScript IT Solutions Private Limited. And here we are calculating the length of the string with the help of length property. So the next one is string methods. So the first method is clone, which will return a reference to this instance of a string. So instead of creating the new string, it will return a reference of existing string variable. So let's understand with the help of this example. So in class program, there is a static void main method. Here we have declared one txt variable of string data type, which contains hello world. Now we are printing the value of txt variable on console. So here, with the help of clone method in string class, we are cloning the object or variable of txt. So clone and txt are both pointing to the same memory location and which contains same data. So the output of the console.writeLine txt and the console.writeLine clone would be same, that is nothing but hello world. Now we are modifying the value of clone variable, that is string is clone. So as we are aware, string are immutable. So instead of modifying the existing value, it will create the new object or new memory in heap memory. So here now txt contains hello world, but clone contains string is clone as a value. So the output would be string is clone. So this line will print hello world because txt contains hello world. After that, we are cloning the object txt and printing the value on console. So both txt and clone contain same value, that is hello world over here. After that, we are modifying the clone variable and not the txt variable. So the output would be string is clone. Even we are modifying the value, the txt contains the same value, that is nothing but hello world, because strings are immutable. So instead of modifying the existing value, here it will create the separate memory for clone variable. But at the initial time, txt and clone both are pointing to the same memory location because both variables contains the same value. So let's understand with the help of Visual Studio. So in static void main method, we have declared two variables s1 and s2. So as we are aware, strings are intern, which means in intern pool, the runtime environment will check whether the string is available or not. If it is available, then that memory would be shared between both variables. So s1 contains hello and s2 also contains hello as a value. So let's debug the application. So S1 contains hello and S2 contains hello. Here with the help of reference equals, we are checking whether S1 and S2 have the same memory address or not. So on console, it will print true because both contains the same value. So from intern pool, runtime environment will assign same value to S1 and S2 because both variable contains the same data and case is also same for both strings. So now we are declaring one more variable, that is greeting, and which contains nice to meet you string. So as we discuss at background level, it would be converted into this syntax. So string is a class, and here we are calling the constructor of string class. So here constructor accepting the array of characters. So there are different overloaded methods of string constructor. So these are the available constructors in string class. So let's go to the definition. So yes, there are different variants are available of constructor over here. So constructor accepting different parameters. So it is also called as constructor overloading. So as we are aware, string is a collection of characters. So we can read the characters from string one by one with the help of for loop. So here we have declared one variable integer I is equal to 0, and we are using the length property to calculate how many characters are available in the string. So right now there are 17 characters are available. So we will iterate the string up to 17 character. So let's print first character from greeting. So yes, n is printed on console. Now value would be incremented, that is I plus plus. Now the value of I is 1. So the next character is I. So like this, we will read each and every character from the string. Now nice to M. We have reached up to M character. So let's run the application. Yes, nice to meet you is printed over here. Now let's understand clone method. So as we discuss, strings are immutable. So here we have declared string original, which contains hello as a value. After that, we are assigning the same value to modified variable. So the output of the both variable is hello over here. Yes, hello. So here hello is printed for first line, and this is the second line. So now we are modifying the value of modified variable to how are you. Now the output of the original variable is still same, that is nothing but hello, and modified variable would be how are you. So both strings are stored at different memory location as soon as we have modifying the value of modified variable over here. Initially, it was pointing to same memory location. So that's why this line returns true, because both contains the same data and same memory address. But now original variable and modified variable are pointing to different memory location because we have modified the value of modified variable. So now it will print false over here because the memory address of original string and modified string are now different. So the next variable is txt, which contains hello world. So let's print the value of txt variable over here. So yes, hello world. Now we are cloning the object txt over here. So now txt and clone contains both or same value, that is nothing but hello world. So let's print the clone, that is hello world. So on console, txt contains hello world and clone variable also contains hello world. Now both are pointing to the same memory location. So that's why reference equal method will return true, because both have same memory address. Yes, it is true. So there is one more method. So as we see here, clone returns the object as a type. So clone data type is var over here. So let's convert this clone object to string data type. Now test also contains hello world, clone also contains hello world, and txt also contains hello world. These three variables are pointing to the same memory address because all of contains same data which is available in intern pool. So if we compare memory address of txt variable and test variable, it would be same. That's why it will print true on console. Yes, it is printing true over here. So here txt contains hello world. Then we are assigning or making the clone of that object to clone. So the same memory address would be shared with clone variable. After that, this clone variable explicitly converted into the string class or string variable, that is test, which also contains the same string, that is hello world. So the memory address for txt, clone and test are same. So that's why it will return true over here. Now we are modifying the clone variable. String is clone and printing that information on console. Yes, string is clone. Now txt and clone are different because we have modified the value of clone variable, but txt and test variable are same because both contains the same value. Yes, hello world and txt is also hello world. So txt and test variable are still pointing to the same memory location, but clone variable is not pointing to that memory location because we have modified the value of clone variable over here. So now we are comparing txt clone, txt variable and clone variable. So as we have modified these values, so the memory address would be different. Yes, it is false. But if we compare txt and test variable, they are still pointing to same memory location. So that's why it will print true on console. Yes, it is printing true on console. So that's it, guys. So hope you have understand why strings are immutable in C# and how the memory is managed by runtime environment in case of string variables.